Hello students, welcome. Previously, Form 2, Topic 2, Lesson 1, we were introducing chemical families and we were talking about alkali metals. So, today, Lesson 2, we are going to see some of the physical properties of alkali metals. So, we have a table here. Here we have elements or members of alkali metals. Remember, we said the members of alkali metals include lithium, sodium, and potassium. Apart from this, we have rubidium, calcium, and also francium. But these three are the first 20 elements in the periodic table. So we have their appearance here, their ease of cutting, melting point in degrees Celsius. We have the boiling points in degrees Celsius. We have their electrical conductivity. We have their atomic radius, which is measured in nanometer. Then here we have their first ionization energy, which is measured in kilojoules per mole. Okay, to start, we are having the appearance. Start with the first, we are having ease of cutting. The first physical property of alkali metal, ease of cutting. So we said the alkali metals have a shiny metallic luster when freshly cut. However, we are told the surface quickly tarnishes. Reason, we are told this is because of reacting with air, or you can say this is due to the reaction with the atmospheric air or oxygen. So next point, we are told the alkali metals are soft and easy to cut. Okay, then we are told the softness and ease of cutting of alkali metals increases down the group. So during the exam, you can be told, state and explain the trends in the easy cutting of alkali metals. So the trend will be the ease of cutting of alkali metals increases down the group. So what is the reason? So to get the reason, we are supposed to relate some two things. Those two things are here, where you are supposed to relate the atomic size and also the strength of the forces of attraction holding the atoms together. Okay, the size of the atom or the atomic size can be small. Like for example, we know that lithium is having a small atomic radius. Even that one, you can see it in the table there. The atomic radius is 0.133. So, its atomic size is small. Next, you can have big atomic size, or you can have large. Then next, to compare, we can have bigger. Or if you're using large, this one will become larger, like potassium. Because the size of atom, the atomic size of potassium is bigger or larger because it has more occupied energy levels than that of sodium and also that of lithium. So when you're having your atomic size as small, that means the strength will be stronger. The strength will be stronger. So that means lithium, which will be having a small atomic size, is going to have a stronger strength. Okay, so sodium, which is having a bigger atomic size, it is going to have now strong forces. If you are seeing here potassium having bigger or larger atomic size, that means it's having a weaker force, or we can have even weak force. So this is for lithium, Li. This is for sodium to represent. Maybe this is for potassium. So to talk about the ease of cutting of alkali metals, the ease of cutting of alkali metals increases down the group. It increases down the group. The way you have seen here, we are told the softness and ease of cutting of alkali metals increases down the group. What is the reason? So the reason is, this is due to the decrease. This is due to the decrease. Check the strength. It is stronger. It became strong. Then it will become weak or weaker. So that means there is a decrease in the strength of the force of attraction holding the atoms together as the atomic size is increasing down the group. To check the atomic size, initially it was small, it became big, then it became bigger. That means the atomic size is increasing down the group, but the strength of the forces holding the atoms together is decreasing down the group. So the reason is, we are going to say this is due to the decrease in the strength of the force of attraction holding the atoms together as the atomic size is increasing down the group, or as the atomic radius. You can put atomic radius instead of atomic size. So you see, as the atomic radius is increasing down the group. Because when you check the table, the atomic radius is increasing down the group. Okay, to check the answer, yeah, we're told this is due to the decrease in the strength of the forces of attraction holding the atoms together as the atomic size. Or you can say even as the size of the atom increases down the group. Or as the atomic radius increases down the group. That will be the reason. Okay, let's go example. Comparing now the ease of cutting of two alkali metals. Here we're told it is hard to cut lithium than sodium. To check now what we have here, lithium is having a small atomic size. That means it is having a stronger strength. That means if something is having a stronger strength, it requires a lot of energy to be cut. Compared to sodium, because now we are comparing two things. When you're comparing two things, you are supposed to use small and larger or big maybe. So if sodium is bigger, it is going to have a weaker force. So that means if you're having a weaker force, then it will be easy to cut with a knife. So here we're saying this is because atoms of lithium are small. Or you can say lithium has a small atomic size or small atomic radius, hence has a stronger strength. Or you can say have a stronger strength of forces of attraction between its atoms or holding the atoms together than sodium, which are having large atomic size, hence are held together by a weak force of attraction holding the atoms of sodium together. That will be the reason.